Hey, it's decimal time. Decimal time. Brought to you by me. Do 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 do. Yo, another video, another fun-filled block of time when you get to listen to me talk about decimals. I don't know what that is. Today it's just solidifying. We've done so many great things with decimals. I think the biggest factor is just remembering all the different ways we can view them and think about them. In terms of, I guess I should also keyword products here, right? That idea of multiplying them. But specifically today, I think we are going to focus a little more on what happens when we do have a decimal and we are multiplying that by another decimal. Okay. We've had some scenarios where it's like less than one decimals, right? Like working with tenths, like we've done that. We've also had scenarios where it's like a whole number times a decimal, and whatnot. But today I really want to focus on what kind of happens when you have, larger values, like maybe like 5 and 3600ths, and you're multiplying by that 17 and 4900ths, right? That's what I mean by a decimal times a decimal. So that's what we're going to get into today. It should be pretty short in terms of the examples, because I think with each one, it is slowing down and stopping and thinking to ourselves, what do we know? Like, what do we know? What questions can we ask about these numbers before we even get into multiplying them? So let's get into it. Let's dive in. Let's start with question number 1 today. Let's see, what color should we make this one? It's going to be pink. Okay, so I don't know. I'm actually going to make this one up. Let's say we have 6 and 4300ths, and we're going to multiply that by 12 and 5/10, or 12 and a half. Okay, so first, what do we know, right? This is always the way I want to think about our approach to this stuff, is like, what do we know? And one of the things we can recognize is that both of these have whole numbers in them. Like, so both of them are dealing with whole numbers and then some decimal parts. So looking into that right away, this is a technique where I know that estimation will be friendly. Now, not only will it be estimation, but I also think we can focus on place value to make sense of this. Okay. So with that being said, if I did a quick amount of estimation and I said, oh, this, I'm going to keep that at like 6, and I'm going to round this to 13. Well, then that means, that's 98. I think I did my math right. 6 times 13 is 98. No, 78. I was off by a lot. Right. And so here you go. This is a really good example right away. It's like, maybe these aren't the numbers I round to, because they don't seem to be very compatible, because I couldn't do that quickly in my head, which I agree with. So I'm actually going to adjust. I'm just going to say 12. Let's round this one actually just to 10, getting me close to 60. I think that will still be helpful, because again, that's the whole idea with decimation, is a little mental math, which means now here's the thing that we have to remember. I'm just going to multiply these two numbers now to help me get there. I'm not going to worry about the decimals. They're going to come in later. That's what the estimation was for. So instead of 6 and 4300ths, I am going to just kind of pretend I have 643. And instead of 12 and 5/10, I'm actually going to have 125. So we're actually thinking of a skill we had to work on earlier, which was 3-digit by 3-digit multiplication. I don't have enough room on this page, so I'm gonna jump to the next page to do that, and I'm gonna rewrite it, and we'll come back to this one. Don't worry, like we'll go back and forth. But it was 643 times 125. So I'm gonna go with an area model, which means I need to expand this out first. So that would be that, and then this is 100 plus 20 plus 5. So let's build an area model. I have 3 rows. I have a row of 600. I have a row of 40 and a row of 3. Again, if what I'm doing doesn't make sense, please go back to the videos online around multiplying with the area model. This could be a great technique that you would use to help you multiply larger numbers. I like when it's 3 by 3, I like using the area model because I feel like I kind of make less mistakes. But again, everyone has their own style. So let's see, 6 times 1 is 6. 1, 2, 3, 4. 1, 2, 3, 4. 1 times 4 is 4. And then there's 3 zeros. This would be 300. Let's see, 6 times 2 is 12. And then I have 1, 2, 3 zeros. 1, 2, 3 zeros. That's where my third one was. 4 times 2 is 8. And there's 2 zeros. And then this is 60, right? 3 times 20. Let's see, 5 times 6 is 30. And then 2 more zeros. And then 5 times 4 is 20. And then 1 more zero. And then 5 times 3 is 15. Okay, so those are all my parts. I'm going to put those together now. I'm going to add those parts together to get my final product. So we have, and I'm going to make sure I write nice and large and space things out. So that's 60,000. I have 12,000. And I have 3,000. Okay, that's the top row. I'm just going to add that first. 0, 0, 0, 5, 7. And then I'm going to do the second row over here. So 400, 800, 200. Right, that's this one. So 0, 0, 10, 14. That's 1,400. I'm going to add that over here, 1,400. And then this last column or row, 60, 30, and 15. That's these numbers. Going to add those up. 5, 9, that's 105. So I'm going to put 105 on here. And I'll just put all these together. So there's a 5, a 0, a 5, a 6, and a 7. So 76505. Let's go back. So by multiplying this, we get 76505. But now remember, what we notice in our estimation is we should have an answer that is around 60. So what's going to make sense for me then is I'm going to put my decimal here because 76 is close to 60. And the other way I can also check this is that place value. So that's the estimation, but place value also states that I can actually go up here and just count that when I ignored the decimals, right? I ignored them to make 643. I'm going to come back and actually count how many decimal place values I have. So I have 1 here, 2 here, 3 here, which means my answer should have 3 in it. And look, 1, 2, 3, it sure does. Maybe do that in a different color. Here we go. 1, 2, 3, and it does. So that decimal does sit in the right place for those. Both those techniques work good. When using 2 whole numbers, estimation works really good with where to put your decimal. You can also just count them and put them back in. So that would be that first one. So let's move on and think about, well, okay, that's a decimal by a decimal, and it really led to doing some big multiplication. Let's tackle something that maybe it's 2 decimals, but it's like 8 and 4300ths, and we're actually timesing that by like 4200ths, right? So again, here's the logic we need to put into this. The first thing I need to recognize is I have 4 holes here, but I have 0 holes here. So even if I was to estimate that, that gets me an answer of 0. That doesn't really help me, right? Because I would round that to like 5, and round this one to 5, round this to 0, that's 0, right? That doesn't help me. So estimation doesn't work in this scenario, but what does work is number sense. So this is what we're talking about here with number sense. And the number sense states this, is that I know that since this is less than 1, then my answer is actually going to be less than 4 8300ths. And so, and also, right, if I think about that, 4200ths, that's actually close to 5000ths, which would be half. So half of what, 4 or 5 is like 2, somewhere around 2. So I have that in mind. So again, my answer is going to be less than 4 8300ths because I'm multiplying by a number smaller than 1. And then I also did kind of use some form of estimation. I just didn't round to a 0 or a 1 to kind of think about half of this. So let's go back and just do the technique. So again, I'm going to ignore the decimals. So 483, I'm going to multiply that by 42. I'm going to use standard algorithm for this one. So 2 times 3 is 6. 2 times 8 is 16. 2 times 4 is 8 plus 1 more is 9. And then I'm going to say 4 times 3 is 12. 4 times 8 is 32, and plus 1 more is 33. And then 4 times 4 is 16.
I forgot my homework.
Oh my gosh, you know what's so cool is I'm actually sitting in your desk right now filming tomorrow's math video. Say hi to everyone.
Hi.
Oh my God, look how cool that is. Now I got to move out of your seat so you can do this. Hi, how are you? So tomorrow, right now, you're going to be watching this video tomorrow and you're going to hear your own voice saying hi in it. How meta is that? Okay. Well, there was a guest appearance by Haley in our own math video. Right on. Yeah, we'll see you tomorrow. And I didn't even press pause, so that's going to be in our video tomorrow. I love it. All right. So there you have it. I love the realness of this. So now, that was great. That was Haley. And I'm literally sitting in Haley's desk while I'm filming this video today. So how fun is that? Where was I? Oh, so now we got to add these together. So I'm going to get a 6 and an 8 and a 12 and a 10 and a 2. So I have a 2, a 0, a 2, an 8, and a 6 is my digits. So remember, one of the things we noticed is this is going to have to be less than 4. So I can't, I can't put my decimal here. That's like 2,000. I can't put my decimal here. That's 202, right? That's not less than 4. I can't put my decimal here. That makes 20. That's 20 holes. That's still not less than 4. And so I could put my decimal here. That would get me 2. That's less than 4. But I also could put my decimal here, and that's 2/10. Well, it's like a bunch of other stuff, but still. And that's actually less than 4, right? That's, in fact, it's less than 1. So now we kind of have this debate of like, where does it belong? Is it in this place or this place? So that's where we could think about just counting place values to make sure. Because if we come up here, we'll see we have 1, 2 place values here. 1, 2 place values here. And remember, we're only counting the decimals in this case. That's what's confusing. I know. There's so many rules, so it's true. This only works when we're doing multiplication of decimals. It doesn't work when we do another thing. So just remember that. So anyway, that means I have 1, 2, 3, 4 decimal place values. So 1, 2, 3, 4, which does put our decimal right there, giving us 2 and 286. I don't know. I don't even know what that is. We never even talked about that. 10,000s? I don't know. Millions? Who knows? But regardless, there's an answer and we have an answer. So that works. Okay, cool. Let's do one more. I'm going to do one last one. And then by all means, just get to it, right? Where are we? Yeah, this is roughly, well, no, you know what? I'm not going to do one more. Let's just wrap this up and think about it because you have this all now. So just remember, pay attention to what's happening when you're working with decimals. Just pay attention to what's happening with those whole numbers, right? And what that means for when you multiply, like what's going to be the results of the things. I'm just going to write a few examples and we're going to talk about that. I don't know. Oh, something like that, right? Okay. So, as we go into like problems with this, before we even solve, we can just start thinking, oh, well, here, well, let me do a better. Okay. We have a whole number and a whole number. So that's a 3 and a 4. So 3 times 4, right? That gets me about 12 holes. Or although you could even argue it's 16 because you could round this to 4. But regardless, that still knows that because I'm working with whole numbers and whole numbers, right? I have things larger than 1, then my answer is going to be larger than either of the numbers I'm multiplying by. And then, we come to something like this where we have 9, but this is less than 1. So what's actually going to happen is I know that my answer is going to be, I guess I should actually just like use the correct answer. The answer is going to be less than 9 itself. It's going to be less than this, right? I don't know. A for answer. So that's another thing to keep in mind. Like just remembering that as we go into it, because I have 7,500s, that's less than 1. If I multiply that by 9 3/10, my answer is actually going to be less than 9 3/10. And same thing here. If we come down to this problem, I have 107, but I have something super small here. Oh, it looks like a guy. Hello, I am a guy. Sorry, that was confusing. Right, we have something way less than 1. In fact, it's less than 1/10. So my answer is going to actually be way smaller than 107. But again, we won't know that unless we just go ahead and multiply, right? Ignoring that decimal and then going through and doing the work, counting decimal place values and whatnot. So I'm going to leave it at that. If you have any questions, by all means, ask. Get the work done. I think that's one area we've run into is just making sure we complete assignments. So please work hard on completing your assignments, getting things done, and asking questions. You're doing great. It's okay to be confused. Don't hesitate to ask. We'll see you at the next video. Bye.